This video is on proving congruent, well, it's not on proving congruent triangles, it's on which test to use should you want to prove that two or more triangles are congruent. So if you're going to try and prove two triangles are congruent, then you need to know the 4 possible tests that you can choose from. So let's quickly recap what you should know at this point in time. And here are my 4 tests, and we're allowed to use these little, I guess they're called acronyms, I think, where each of these letters stands for something. So you'll need to know what they stand for, and you'll need to know what the tests actually mean. So side, side, side means that if you have one triangle with 3 certain sides, so here it's these are 2 scalene triangles where you can see from the markings that each side is a different length. We've got a single dash, a double dash, and a triple dash. If you have a second triangle with those exact same side lengths, so here's this single dash means that these 2 sides are the same, and then we've got both with the double dash, so that means these 2 sides are the same, and then we've got a third pair with a triple dash, meaning that these 2 sides are the same. So if we have 2 pairs of triangles with 3 equal sides, then they are congruent. And just a reminder that if they're congruent, it means they are the same shape and the same size exactly. So they are identical, really. Now, the next test I like comes from side, 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 or I think of it as coming from side, 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 because if you happen to know that the hypotenuse and another side in a right-angle triangle are equal, it's terrible markings. So if I happen to know that 2 right-angled triangles share, say, a hypotenuse, and then another side is also the same, then you can actually work out the third side using Pythagoras. But what it means is, because of Pythagoras' theorem, this third side would have to equal that third side. So I always think of this test of right angle hypotenuse side coming from side, 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 because really it's like saying if you have 2 sides, then you'll get the third side, but you don't need to prove it. You can conclude that the third sides must be equal. So as soon as you have a right angle, that's what the R stands for, 2 hypotenuse that are the same length, and 1 more side in a right angle triangle, then that's enough to establish that these 2 triangles must be identical. That means they are exactly the same shape and the same size, and that means they are congruent. My next test requires you to have 2 sides, 2 pairs of corresponding sides. So that's when you hear this word corresponding sides, very important, because it means that the position or where the side is placed is actually important. So I've got in this diagram, there's 1 pair of corresponding sides, and then I've got another pair of corresponding sides, and then here's a new important word, the included angle. So that angle there, they're called included angles. The included angle is really important language for you. The included angle means that the angle sits in between the 2 sides. So if you have 2 sides, an included angle will be in between those 2 sides. Okay, so if you've got 2 sides of any figure, the included angle sits in between them. And to use SAS, it's side included angle, so must be the included angle, not just any angle, but the included angle. That will mean that the 2 triangles are congruent. My last test is angle side. So you can have any 2 angles in the triangle and a corresponding side. So let's talk about what that means. If I look at these 2 triangles, there's my pair of equal angles, there's another pair of equal angles, and notice how they sit. Okay, they both touch the corresponding side, and that's what allows them to be congruent. You can have angle side, so here's another angle, and then let's color in this other angle here, but notice where the side sits. Okay, the side is opposite this double angle here, and it's opposite the double angle in both the triangles. So if I was to draw another triangle, let's do that again. I was to draw another triangle with the double dash, but this equal side happened to be over here, and this opposite from this angle, okay, then this triangle would not be congruent to those 2 triangles. It is very important that the corresponding side in both the triangles are in the same place, meaning they are opposite the same angle. So just be very, very conscious of that when you're using angle side. So it's the 2 angles and the corresponding side in both triangles. So 2 pairs of corresponding angles and sides, and a pair of sides are equal in both triangles. All right, so we've got 4 tests to choose from. Here's 3 diagrams, and what I'm going to do is I'm going to label them. I want you to notice it's all the same, was practically the same diagram for each one, but I'm going to come along and I'm going to label them all differently. And what's funny is when I label them differently, it means that I use a different test for each one. So I need you to be aware of the fact that you can't just assume to use the same test. You have to have the evidence of those sides and angles in order to use that test. So if we look at the first diagram, if you're confident, pause the video, write down what you think the test will be, and then unpause and compare it with my answers. So here, what we clearly have is a right angle. Okay, and everyone thinks, oh, straight away I'll do right angle, hypotenuse, side. Well, let's check it. There's the right angle. Do I have the hypotenuse as equal in both these triangles? Yes, I do. Now I've got to find another side. Where is that side? Well, be conscious of common sides. A common side is a side shared by 2 triangles, or it's just a shared side, so it could be shared by other shapes other than triangles, but it's a side shared. So there's my shared side. So that gives me R over here. Oh no, that's hypotenuse, isn't it? There's my hypotenuse. There's my right angle, and here's my side. So I do in fact have RHS. Now over here, I want you to notice I have not provided any markings on the 2 hypotenuse in both the triangles. So we really can't use the fact that the hypotenuse are the same length because I haven't told you that they're the same length. So I'm going to go with, here I've got a side, and I've also got this common side that I marked before, and I want you to notice I've got a side and a side, and look at here, I've got an angle in between those 2 sides, an included angle, that happens to be the same in both triangles. So don't forget what we said before. If you've got one side here and one side there, the included angle doesn't have to be a right angle, but the included angle sits in between the 2 sides. So I have side, then I've got included angle, and then I have side again. So for this set of triangles with different markings, I will be using SAS. If I look at this last diagram, I have not marked the right angles. They are not there anymore, okay? And that means you can't assume, even if they look like right angles, that they are right angles. Do not assume anything. So for this one, well, I've got my hypotenuse. They're marked a bit funny. I noticed that just then. So I might mark them a bit down here. What I do have is I have a side again. So there's my side. Then I've got that angle's been given to me as equal. I've got an angle. And then I've got my shared side, or a common side. That's the other way of calling it. So here I also have side angle side. So just be really conscious of using the information on the diagram and not making any assumptions when it comes to which test to use. All right, which test to use here? Now, I'm hoping you'll notice these parallel lines because they're very important in deciding which test to use. When you have parallel lines, you'll need to think back to year 7 or year 8 where you did angles on parallel lines. And the ones that I'm going to use are actually called alternate angles. And you can look for the letter Z to find alternate angles. I'm going to try and find that letter Z on my diagram here. I can see there's a Z right there. And with your Z, the very important part is the 2 lines that form the Z, or the top and bottom of the Z, must be parallel. So when you're drawing your Z, these 2 lines here have to be parallel. And I can see that. I've got them there and there. So when you've got alternate angles, well, the markings sit here, but one of the alternate angles will be there, and the other alternate angle is there. So there's one, and there's the other. But I actually have more than one Z. I might rub out this first one and put in the other one so it's easier to see. And I've got another Z looking right there, okay? And once again, the top and the bottom of the Z are parallel, and so my other alternate angles will be here and here. And if you then look what I've got an angle, I've got another angle, and I actually have a common side in triangle 1 and triangle 2. So the test I can use is angle. There's one set, the green dots, angle. That's this red arc. Let me colour it in if it's not clear. And then I've got this common side. What can I mark it with? Something a bit dark. This blue common side now, which gives me angle, angle, side. So that's the test I would use. Now, for those of you who are thinking, oh, it's a parallelogram, why can't I use that? It is a parallelogram because opposite sides of a parallelogram are equal, and that's enough to prove it's a parallelogram. But once you get it's a parallelogram, you'd have to then go on to say, well, opposite sides of a parallelogram are equal, so therefore these two sides are equal, and then you've got this third common or shared side. So you could actually use SSS, but that's definitely a lot more work because first you would have to establish that the quadrilateral was a parallelogram. All right. Last question. So here we've got an angle. You can already see that. I've got a side, so that's good. But I don't have anything else. I've got no more markings. I'm hoping you will notice that this angle and this angle, well, they're called vertically opposite angles. Okay, vertically opposite angles are angles that are formed when you've got two lines that cross each other. Okay, so when they cross each other, they don't have to. You don't need any parallel lines or anything. Wherever they cross each other, those two angles opposite each other are equal, and so are those two angles over there. So actually two pairs of equal angles. So the blue angles are the same. So I've got angle, that's this angle here, these red ones. And I've got the blue angles, that gives me another one. And then I have these two sides. And if you look, the blue dash is opposite the dark blue angle in both the triangles. So the corresponding sides are in the correct place. Right, which congruency test to use here? So have a think, pause the video, and give yourself a bit of time, and then I want you to unpause it, and hopefully our answers match. I'm really hoping you're going to tell me something in particular about what you notice in both the triangles. So pause, and then unpause when you're ready. All right, what I want you to tell me is that, well, basically I have no side lengths being marked. So I've got no sides that I can comment on. What I do have is angle, and I've got another angle, another pair of corresponding angles, and I have another pair of corresponding angles. That is angle, angle, angle. Now, if I go back to my slides, is there an angle, angle, angle test? Not there, not there, not there, and not there. There is no angle, angle test, angle, angle, angle test, and these two triangles are not congruent. Okay, you can even look at them, although I have to say diagrams aren't drawn to scale, but this one is bigger. Okay, and congruent figures are identical, okay, and there is no angle, angle, angle test, because what can happen is you can actually draw, if I was to draw a triangle like this, and then I was to create a parallel, if I was to extend the sides and draw more and more parallel lines, so make all of these parallel, what you would notice is they would all share, so I'm talking about this triangle and then the bigger triangle and then the biggest triangle, they would all share, because of the parallel lines, these three angles would be equal because they're actually all corresponding angles, and these three angles would be equal. So what you've got is this first triangle, let me see if I can get some colours. Yep. That first triangle has exactly the same angles as this second triangle, which has exactly the same angles as, let's go for purple, this very last triangle. So what does that mean? Well, three angles is not enough to establish congruent triangles. In fact, we can see that when you have three angles, the triangles can in fact be enlargements of one another, not necessarily the same size. So AAA is not a congruency test. So here you can see you've got an angle, you've got a right angle, and then you can even go, oh, I've got vertically opposite angles, but it doesn't matter because you've got no sides. So these two triangles we will not be able to prove are congruent because AAA is not a congruency test. All right, hopefully this video helps you on which test to choose.